Before a star settles into the steady, predictable behavior we associate with something like our Sun, it goes through an unruly adolescence, and one particular class of young stars barely holds still. Named after the first well-studied example in the constellation Taurus, T Tauri stars are young, low-mass stars, still contracting under their own gravity, not yet hot enough at their core to sustain full, stable hydrogen fusion. They typically range from less than 1 million to about 10 million years old, genuinely young by stellar standards, considering stars like the Sun live for billions of years. The namesake star itself was first noted as unusual in 1852 by English astronomer John Russell Hind, who observed it varying in brightness in ways nothing else nearby did, though it took until the 20th century for astronomers to understand why. Unlike a mature, stable star, a T Tauri star's brightness can swing unpredictably, sometimes dimming or flaring within days, driven by a swirling disk of leftover gas and dust still spiraling onto its surface. That disk is often the same material that will eventually form planets. As chunks of it fall inward, they release bursts of energy, making the star flicker in ways a stable star like our Sun never would. This behavior, called accretion variability, can change a T Tauri star's brightness by a full magnitude or more within days, dramatic enough that early observers sometimes mistook individual young stars for entirely new objects appearing in the sky. Many T Tauri stars also fire narrow, high-speed jets of gas out from their poles, sometimes stretching for light years, slamming into surrounding interstellar gas and lighting up in glowing knots called Herbig Haro objects. These jets appear to help the young star shed excess angular momentum, a kind of pressure valve that lets it keep contracting toward a stable state without spinning itself apart. The knots are named after astronomers George Herbig and Guillermo Haro, who independently studied and catalogued them in the 1950s, decades before anyone understood they were tied to newly forming stars at all. Over tens of millions of years, the disk material either falls onto the star, gets blown away by its own stellar wind, or clumps together into planets, and the wild flickering gradually calms down. Once the core finally reaches roughly 10 million degrees Celsius, sustained hydrogen fusion ignites, and the T Tauri star settles into the long, stable adulthood we associate with an ordinary main sequence star, much like our own Sun did 4.5 billion years ago. Subscribe for more of what a star's early years actually look like.